Good evening, everyone. Good evening to everyone. I'm audible to you guys? Good evening, everyone. Good evening, guys. Okay. Okay, so in the last class, I'll start. So in the last class, what we saw is, all of you got the notes? All of you got the notes? Give me a thumbs up. All of you got the notes? Huh? Do you guys got the notes? Good evening, good evening. Okay. So again, sir has already told you, go to the description box, and join the Telegram channel, and through that you can get the notes. Okay. So in the last class, what we saw is that there is something called as acid. So what is acid? Let us say you are having HX, a given compound, and if you put the HX into the water, it will dissociate into H plus plus X minus, right? Now, there is a term related. We have done the nomenclature of acidic radical and basic radical. Let me define you what is acidic radical. So, acidic radical, what is acidic radical? See, how to remember? Please remember like this. A for anion. Acidic radical. A means anion. That means if you remove H plus, according to the definition, if we remove H plus, whatever is the negative charge is formed, that is called as acidic radical. Let us say we are having a base. NaOH. What is the definition of base? If you put the NaOH into the water, it will dissociate OH minus. If it dissociate OH minus, so Na plus and OH minus, isn't it? So, you see over here, what is acidic radical? Acidic radical means negative part of the acid. A for anion. Remember like this. A for anion. This is called as acidic radical. Similarly, if you look for the base, acidic radical. Similarly, if we have base, it will furnish OH minus, and because it furnishes OH minus, what will happen? This positive part. So we are having acidic radical, and this is basic radical. So because acidic radical is anion, basic radical will be cation. Very simple definition, I guess, right? If you remove H plus, whatever is left, acid ka radical. Base, what is the definition? If you remove OH minus, what is left? That is basic radical. Remove H plus, whatever is left, acidic radical. Remove OH minus, whatever is left, that is basic radical. For example, let us say that we are having barium hydroxide. So barium hydroxide is a base, because we know that this, if you put them into the water, this will dissociate at what? 2OH minus plus bolo beta ji barium 2 plus. So because base, if you remove OH minus, what is left? Ba2 plus. So this will be called which radical? This will be called as, I hope very clear, this will be called as bolo beta ji basic radical, right? If you take any acid, for example HBr, if I'll take HBr and you put them into the water, dissociation H plus and Br minus. So if you remove H plus, whatever is formed, that is called as acid ka radical. Is this definition clear to everyone? Acidic radical, basic radical. Just give me a thumbs up. Is this definition clear to everyone? Acidic radical, basic radical. Definition clear to everyone? Just give me a thumbs up quickly, please, guys. Okay. So we have already done the nomenclature. Now we are continuing with the electronic configuration. To continue with the electronic configuration, let us see how to go about it. Okay. So, okay, let's start. So, electronic configuration. Now, to understand electronic configuration, to understand electronic configuration in a proper way, how to do it? To understand the electronic configuration, the configuration we have studied in high schools are, there is a nucleus and these are the orbits. In the first orbit, there should be 2 electrons. In the second orbit, there should be 8 electrons. Third orbit, 8 electrons. Fourth orbit, 18 electrons. Like that, we know the electronic configuration. But that is not sufficient in the 11th and 12th class. Because you will see many chemical properties cannot be defined with this configuration. And anyway, this configuration is based on the Bohr model, and you'll study in 11th class that Bohr model is not a sufficient model to explain all the properties of an atom. So which model will come into the play? Quantum model. Which model will come into the play? Bolo beta ji, quantum model will come into the play. And once quantum model comes into the play, what will happen? Quantum model, quantum theory. We don't have sufficient time to discuss quantum theory, but anyways, naming of P4O6. What is the doubt, beta ji? That is also called as phosphorus trioxide. It is also called as phosphorus trioxide because of its structure that we'll study in chemical bonding. For now, you stick to tetraphosphorus hexoxide. Now you stick to that. Later you will see it is also called as phosphorus trioxide. We are not going into that. We don't have time. Okay. So, quantum theory. So, from quantum theory, this is the new theory which explains everything about the structure of an atom. Quantum theory. We are not going into detail of that, but quantum theory. So from quantum theory, we have an equation which is called a Schrodinger equation. You will start in 11th class. There is in atomic structure chapter, there is something called a Schrodinger equation. So once you solve, this equation looks like this: H psi is equal to E psi. Now we are not going into that, what is this equation, but this is a Schrodinger equation. With the help of Schrodinger equation, we are going to find out few quantum numbers. For example, if you have a quadratic equation, you solve the equation and you get the value of x, right? Similarly, from this equation, some solutions are found. Don't worry, what is this equation, sir? How to get this equation, sir? Forget about that. That is not the part of us right now. For now, solutions, right? Now, in the case of solutions, जैसे quadratic equation का solution, similarly this equation will give some solutions of equation. And what are those solutions? Those solutions are known as quantum numbers. Because it is given by quantum theory, so they were called as quantum numbers. From where the quantum numbers came? From the solution of Schrodinger equation, quantum numbers came. Okay. Now, once we have the knowledge of quantum numbers, so what are quantum numbers and how many type of quantum numbers do we have? Let us go to that. So, there are 4 kinds of quantum numbers, beta ji. 4 kinds of quantum numbers. First one is called as principal quantum number. First quantum number is called as principal quantum number. You'll study more in detail for these numbers. For now, I'm not going into much detail. I'll go to till that point, which gives us the idea about electronic configuration. So we'll try to, concise the points. I'm not going into detail of all these things. So principal quantum number ka symbol is small n. So first quantum number is principal quantum number. What about the principal quantum number? So principal quantum number gives us the energy. Principal quantum number gives us the energy of orbit. Very good. So what is the information we are deriving from the principal quantum number? Principal quantum number gives the idea of energy. So you'll derive a formula. Once you'll study Bohr model, you'll derive a formula E, energy of nth orbit. For example, let us say we are having first orbit, second orbit, third orbit. So nth orbit ka energy will come minus 13.6 z square by n square. What is z square? Z represents here atomic number, Z represents atomic number, and n represents principal quantum number. Principal quantum number is nothing but orbit number. Principal quantum number is nothing but orbit number. So for any given orbit, whether it is 1, 2, 3, for any given orbit, we can find the energy. Z is atomic number, n is principal quantum number, which is nothing but orbit number, right? So with the help of orbit number, we can find the energy of a given orbit. N could be, bolo beta ji, 1, 2, 3, dash, dash, dash. So this is the first quantum number, which is the solution of Schrodinger equation. With the help of this quantum number, we find the energy of a given orbit. So this is the first quantum number. What is the second quantum number? Second quantum number is called as azimuthal quantum number or orbital angular momentum quantum number. Orbital angular. Why orbital angular momentum name? Beta ji, these things you'll understand in your 11th and 12th class. Orbital angular momentum quantum number. So either we call azimuthal quantum number or it will be called as orbital angular momentum quantum number. Okay. So what is the orbital angular quantum number? So this is represented by symbol L. Orbital angular momentum quantum number is represented by L. What is the information we are getting from L? So orbital quantum number tells us about the shape of orbitals. So this gives the information about shape of orbitals. Now confusion comes. Sir, till now you are talking about orbit, right? Ki energy of the orbit. Suddenly you have started to speak about orbital. Now there are two terms. One is called as orbit and one is called as orbital. Are these two terms same? Are these two terms different? Can anybody give me the difference between orbit and orbital? Can any one of you give me the difference of orbit and orbital? Are they same? Different? If they are different, how come they are different? Anybody can give me definition? What is the difference between orbit and orbital? Are they same or they different? Give me information, please. Anybody? Different. Why they are different? Orbital is inside orbit. Have you seen orbit and inside orbit? How you have seen that? Orbit means path, yes. Orbital means a part of orbit. Okay, so we are having very vague information. An orbit is a fixed circular path, but orbital is a three-dimensional region where an electron is like. Very good, beta ji. Very good, Jitendra. Very good, beta ji. Yes. So that is the definition of orbital. So orbital is please remember, orbital is the concept of quantum mechanics. Orbital is the concept of quantum mechanics. And orbit is the concept of classical mechanics. Classical mechanics means Newtonian mechanics. Newtonian mechanics. Classical mechanics is the Newtonian mechanics. Probability of finding maximum electron. Very good. Akshat, very good, beta ji. Very good. So orbit is the classical mechanics. Basically, orbit comes from the Bohr model and orbital comes from the quantum model, quantum mechanics. So it only gives the probability. It will never tell you how much, exactly where you will find the electron. It doesn't give any information about that. But in orbit, you will get the exact path. In orbital, we don't have path. I'm not going more detail into it. But simple idea is orbit and orbitals are different. They are not same. Please remember. So principal quantum number tells you about orbit ka energy. And azimuthal quantum number or orbital angular quantum number tells you about L value. And what L represents is shape of orbital. L will represent what, beta ji? Shape of orbital. Now, how the L values vary? So L value varies from 0 to n minus 1. L value varies from 0 to n minus 1. Let us say that if I will say n ka value is 2, so what will be L values, bolo beta ji? For n is equal to 2, L values are equal to what? 0, 1. If n value is 2, L values will be 0 and 1. Okay. Now, what is this 0 meaning and what is this n1 meaning? So, L ka value 0 means what? This means s orbital. Which orbital? S orbital. L ka value 1 means what? P orbital. L1 means what? P orbital. And what is the meaning of 2? Let us say n ka value is 4. If I'll say n ka value is 4, in that case, what are the orbitals? N is equal to 4 means L is equal to 0, 1, 2 and 3. So L is equal to 0 means S orbital, L is equal to 1 means P orbital, L is equal to 2 means D orbital, SPDF, and N is equal to 3 means F orbital, right? So 0 L means S orbital, 1 means P orbital, 2 means D orbital, 3 means F orbital. Now, some of you are confused. What is the meaning of this, sir? What is SPDF? What you want to explain with SPDF? Okay, let us come to that. What is SPDF? So, as I have already told you, S means what bolo beta ji? Shape of orbitals. S means what bolo? L value means what? Sorry, L value means shape of orbitals. So how come these shapes will look like? Let us come to that. I'm not going into detail of that. These are all applications of quantum chemistry. Again, it is very detailed topic. You won't cover entire topic in 11th and 12th class, but you will get the idea. I'm not going into that for now. I'm simply looking at the shape of the orbitals. Let us come to this. So S orbital. So what is the value of L for S orbital? L value is equal to 0. So what is the shape then? Shape it's like this. So this is the nucleus. Around the nucleus, this is the S orbital. So this is the shape of S orbital. I can draw the S like this. So this is S orbital, something like this. So this is S orbital. So there will be somewhere over here there is the nucleus, and around the nucleus there is electron density. So you don't have any exact idea where is the electron density. There is no exact idea. There is the probability which is actually given by psi square. We are not going into that. But this is the most probable area where you can find the electron. So basically that is called as boundary surface diagram. So you find the dot like this, dotted like this. Anyways, so this is S orbital ka shape. So what is S orbital ka shape bolo beta ji? This is spherical. S orbital ka shape is spherical. Actually, these symbols S, P, D, F came because of their nature of orbital. Nature of orbital. What is means in nature of orbital? No, you cannot put S, P, D, F, K, L, M, N. No, beta ji, no and never. So what is meaning of S? S means what we observed is there is something called as emission spectrum. You will study in your 11th class, emission spectrum. Just remember, in emission spectrum, these lines were called as S line was sharp. So there is a line which was very sharp. For that we gave the name S. There was a line which was principal lines. For that it was actually see, one is diffused, one is sharp, and one line is not very diffused, not very sharp. So they were called as principal lines. Sharp lines, principal lines, right? And one was diffused. Lines were diffused in the spectrum. Diffused. And F was called as fundamental. So fundamental. So S orbital is spherical in shape. So this is spherical in shape. What about P orbital, sir? P orbital ka L value is equal to 1. Very good. P orbital ka L value is 1. How it looks like? Let us see. So P ka shape is dumbbell shape. P ka shape is dumbbell shape. This is the dumbbell shape. So this is P orbital. This is P orbital. Is it clear to everyone? This is P orbital. We'll explain. Beta ji, difference between SPDF and KLMN is KLMN is the orbit number. SPDF is the orbital. Right now we can't go much in detail. Just understand these are different, not same. So this is P orbital. Next one, we are having D orbital. D orbital means what? L value is equal to 2. L value is equal to 2 for D orbital. Okay. So what is the shape? Shape is double dumbbell. Shape of D orbital is double dumbbell shape. How it looks like? Something like this, double dumbbell. So it is not one dumbbell, these are two dumbbells called as D orbital. Okay. Next one is F orbital. F orbital ka shape is complicated. S orbital ka shape is complicated. Three-dimensional complicated diagram. We cannot draw it here. So this is complicated shape. So we are having four types of orbital based on L value. L is equal to 0, S. L is equal to 1, P. L is equal to 2, D. And L is equal to 3, F orbitals. You can write more values. So let us say L0. So for L0 you have which orbital? S orbital. For L1, P orbital. For 2, D orbital. For 3, F orbital. For 4, G is SPDF G. Okay. So G orbital like that. H orbital, I orbital. J is omitted. J is omitted. J को use नहीं करते. Other than J, you can continue alphabetical order. D, F, G, H like that. You avoid J value. Okay. Great. Now, so these are the orbitals. Now we are coming to the third quantum number. So first quantum number gave us the energy of the orbit. Second quantum number gave us the idea of orbital, where there is actually finding. When I draw like this, no beta ji, it means that around the nucleus, this is how the electrons are found. Around the nucleus, these are the electrons found. Therefore, they were called as D, because it is diffused in shape. You see, electrons are diffused. I can't go more detail, beta ji, please understand, because we don't have time. So this is called as D orbital. Okay. Third quantum number is called as orbital ho gaya. Third one is called as magnetic quantum number. Magnetic orbital quantum number. Magnetic orbital quantum number. Magnetic orbital quantum number. Now, what about orbital magnetic orbital quantum number? So this is represented by symbol ML. This is represented by symbol ML. Value. ML varies from minus L के बाद क्या आएगा बोलो बेटा जी, minus L to plus L. What it means is, I'll explain you. Let us say that we are having L is equal to 2. What we are having? L is equal to 2. So for L is equal to 2, what are ML values? So it starts from minus 2 goes to plus 2. So minus 2, then minus 1, then bolo beta ji 0, then what will come? Plus 1, and then what will come? Plus 2. L is equal to 2 ml, minus 2 minus 1, 0 plus 1 plus 2. Right? So ml is equal to how much? So what will be the ml value? Total ml values is equal to, the formula is what? 2L plus 1. Formula is 2L plus 1. For example, look at this. L is equal to 2. 2 2s are 4 plus 1, 5. We are having how many values? 5. 1, 2, 3, 4 and 5. So what will be total ml values? 2L plus 1. And how it varies? It varies as minus L to plus L. Now the question is, sir, what it represents? What is the significance of orbital quantum number? What is the significance of orbital quantum number? So basically this gives the information about, what? It gives the information about orientation of orbital in space. Orientation of orbital in space. Orientation of orbital in space. How they are oriented in the space. What it means, sir? It means that, let me explain to you. Let us say that I'm having L value is equal to 1. L value 1 means, what are the ML values, bolo beta ji? For L is equal to 1, what are the ML values, please? ML values is minus 1, 0 and plus 1. So these are the three values we are having for ML, isn't it? Now let us come to it. ML values minus 1, 0, 1. Now what are the different orientations? Again, this is the application of quantum mechanics. So let us say that, what is the shape? What is the shape? L is equal to 1. What is the shape, bolo beta ji? P orbital, isn't it? P orbital. So for P orbital, what is the shape? Dumbbell shape. Dumbbell shape. Very good. Now this dumbbell, how it is oriented in the space? This dumbbell, how it is oriented in the three-dimensional space is given by magnetic quantum number. It is given by magnetic quantum number. Let us come to that. So how it is represented? So it will be 3 because there are 3 axes. So minus 1, let us call Px, Py and Pz. Minus Py, Px and see, I'm not saying minus 1 means Px. Don't get me wrong. I'm not saying minus 1 means Px. You can have Px, Py, Pz. Any number. Again, it is the application of quantum mechanics. I'm not going into that. I don't want to confuse you. What I'm saying is, for now, hypothetically, there will be 3 numbers to 3 axes. One will be Px. Anybody can be anything. Actually, that also I can fix. But now we won't go into detail of that. Okay. 1 means S orbital. 1. No beta ji. L is equal to 0 beta ji. L is equal to 0 means S. L is equal to 1 means P orbital. Okay. Okay. So for L ML values, so this is Px, Py and Pz. So sir, how we are going to represent Px orbital then? Okay, let us see. Px orbital, 3 axes, 3 orientation. Px means along the, let us say this is x-axis and this is y-axis. So along the x, Px, along the y-axis, Py orbital. This is Py orbital. And let us say some axis is z-axis, somewhere over here. Let us say this is z-axis. So along z, this is called as Pz orbital. So what it represents, bolo beta ji? What it represents? Magnetic quantum number represents orientation of orbitals in 3 dimension. What it represents? Orientation of orbital in 3-dimensional space. That is the application of magnetic quantum number. Is it clear to everyone? These 3 quantum numbers are clear to everyone? Just give me a thumbs up, please. We are not going into detail. Are x, y, beta ji, you can do anything. It is up to me. I can have x axis, y axis, up to me, beta ji. Just give me a thumbs up, please. These 3 quantum numbers are clear to everyone? Give me a thumbs up quickly, everyone. Okay, so now we are coming to the 4th quantum number. Now we are coming to the 4th quantum number. Achha, chalo, I'll take one more example. If some of you are not understanding, we'll take one more example. Okay, let us say L value is equal to 2. This is D. This is called as D subshell. D subshell. D subshell. So, what are the ML values? ML values. This is not shell. K, L, M, N, they are the shells, right? D is the subshell. In this D subshell, we are having 5 orbitals. What are those orbitals? ML value -2, -1, 0, 1 and 2. So there are 5 D orbitals. In D subshell, there are 5 D orbitals. What are that? So this is dxy orbital, dxz orbital, dyz orbital, dx square y square orbital, x square actually. This is minus. Why this is minus? Because of phase. I'm not going into that right now. I don't want to confuse you. And one is called a dz square. Sir, how do you get all these things? How do we know what is xy, xz, yz, z square? I don't know, sir, these things. No need to know right now. You'll get to know in the 11th class. For now, let us say that if L value is equal to 2, ML values will be these, and therefore there will be 5 D orbitals. That means different orientation. For example, let us say dxy. So what is dxy? So this is x-axis, y-axis. So this is dxy in between x and y plane. I can't go more in detail for now. So we are continuing with this. So we have understood the 3 quantum numbers. Now coming to the 4th quantum number, which is called a spin quantum number. Which is called as spin quantum number. Now let me repeat. Solutions of Schrodinger equation. Solutions of Schrodinger equation. Solutions of Schrodinger equation gave only 3 quantum numbers. Gave only 3 quantum numbers. 3 quantum numbers which are principal, azimuthal and orbital angular momentum quantum number. Spin quantum number was found out later with the Stern and Gerlach experiment, which is again in quantum mechanics. So from Stern experiment, spin quantum number was devised. So what was the need for spin quantum number? Again, study emission spectra. So there will be certain spectral lines. You will study better. Just believe me for now. There is something called a spectral line. And once the magnetic field were applied to these spectral lines splitted. They will split into more spectral lines. So people started to think, what is the logic behind that? Why they are splitting in the presence of magnetic field? Okay, so how they are splitting is, people imagine like this. Okay, so if there is electron, an electron is revolving on its own axis. Electron is revolving on its own axis. If electrons revolve on their own axis, they have 2 directions of revolution, isn't it? 2 directions, one clockwise and one might be what, beta G, anti-clockwise, something like this, isn't it? One will be clockwise and one will be anti-clockwise. It is like, Earth revolving on its own axis. When Earth revolves on its own axis, you have 2 magnetic poles, south magnetic pole and north magnetic pole. What I mean is, you are having 2 poles, N and S. And when the orientation happens, revolution happened, pole got changed, it became south and north. So that is the basis of spin quantum numbers. So we have 2 spin quantum numbers, one will be clockwise spin and one will be anti-clockwise spin. How they are represented? They are represented like this. This is one spin and this is another spin. If you want to say this is plus half, if you want to say this is plus half spin, this will be called as minus half. If you will say this is minus half, this will be called as plus half. This is not up to us, huh? You can take any value. This is up to us. You can take this as plus half or minus half. But if you take this spin to be plus half, this has to be minus half. And if you take this as minus half, this has to be plus half. So this is half spin. One line divided into two. One line divided into two. Half spin and half spin. One will be plus half, whatever, clock, anti-clock. There is no, it is not like this, it should be clockwise, then it will be plus, nothing like that. Clockwise, you can have plus as well as minus. But if you take one as plus, other has to be minus. Is this quantum number clear to everyone? Give me a thumbs up, guys, quickly. Is this clear to everyone? Give me a thumbs up quickly, please. Spin quantum number. Spin quantum number, guys, give me a thumbs up. So electron revolving on their axis. The electron revolving on their axis like planet revolve on their axis, because planet has two poles, now north pole and south pole. So these poles will change, therefore spin will also change. How do we represent? We represent like plus half and minus half, because one line divided into two, plus and one is plus, half and half. And because of their opposite spins, opposite signs, because north south and south and north. So one will be plus, other will be minus. Now once we have understood the quantum number, now we can try for electronic configuration. Okay, so now we want to go through what is the relation between orbital, and quantum number, and then we can go for the configuration. What is the difference between orbital and quantum number? Let us come to that. Okay, so let us say I'm taking the quantum numbers and we'll come to the orbitals. Let us say I'm having n quantum number, l quantum number, m l quantum number, and then what we will have? We will have orbitals. Listen better, everyone. N value represents energy or orbit. N represents orbit. Now, everyone, please focus. So now, once we are having orbit over here, now what I'm going to do is, I'm going to pick certain values. Let us say n is equal to 1, first orbit. First orbit, beta ji, first orbit, n is equal to 1. So n is equal to 1, what will be the L values, beta ji? What will be the L values? L values will be equal to 0, as L values from 0 to n minus 1. 0 to n minus 1 means what? Only 0. L value 0. So what are ML values, bolo beta ji? ML values, what are the ML values? Minus L to plus L. This will be also 0. So because we are having 0 and 0, and we are having only one quantum number, 1. So how we are going to represent? Listen carefully, beta ji. This is written as 1. Okay, let me put it here. Orbitals ka representation is like this. N, S, let us say some number x. So what is this N? N represents principal quantum number. What is the S? S represents azimuthal quantum number. What is X? X represents number of electron in the orbital. Number of electron in orbital. Number of electron. Okay, now let us come to this. We have only one, L0, M0. So for L is equal to 0, which orbital? L is equal to 0, what is the shape of orbital? Very good, S. Therefore, we are going to write 1s, 1s. This is the symbol of the orbital, 1s. Magnetic quantum number orientation, but there is no orientation. Why there is no orientation? Because S orbital is non-directional. All directions means no direction. All directions means no direction. So there is no direction, no orientation of S orbital. No orientation of S orbital, right? So therefore 1s, no xy, no xz or nothing, no axis, without orientation, okay? Okay, let us say n ka value 2. If n ka value 2, what are the L values, bolo beta ji? 0 and 1, very, very good. 0 value and 1 value. For 0 value, what do we have? For 0 value, ML value is also 0, but the quantum number is 2. So this is represented as, bolo beta ji, 2s, very, very good. This is represented as 2s. What about 1? For 1, what is the shape? For 1, what is the shape? Bolo beta ji, L is equal to 1? P, very good, P. And for L1, what are the ML values? What are the ML values for 1? ML value varies from -1 to +1, very good. So -1, 0, comma plus 1. So we are having 3 set of orbitals. For one L is equal to 1 subshell, we are having 3 set of orbitals. How we are going to represent, please let me know. So this is what? 2p. 1 के लिए क्या आएगा बोलो बेटा जी? 1 के लिए क्या आएगा? p. 1 के लिए क्या आएगा? p. I hope this is clear to everyone. So 2p, 3 set of orbitals. So 2px, comma 2py, comma 2pz. I hope this is clear to everyone. Now let us go to the next one, beta ji. Next one, please. So what is the next one? Let us say L, this value is equal to 3. If this value is 3, 3 possible L values, 0, 1 and 2. 3 possible L values, 0, 1 and 2. Now, 0, 3, 0. What is 3, 0? ML value becomes 0. ML value 0 means no orientation. So 3, okay, 3 sir, fine. What about this one? 0 and 0. So this is nothing but 3s. Okay, what about 1 sir? 3 ka 1 combination. Okay, for 1 we know that ML values will be minus 1, 0 and plus 1. Very good. So for 3 minus 1, now this is 3p orbitals. 3p orbitals. But what is the quantum number? Principal quantum number? 3. So this will be 3px, comma 3py, comma 3pz. Very good. Now for 2. For 2 sir, what is ML values? ML values varies from minus L to plus L. Minus L to plus L means minus 2 to plus 2. Minus 2 to plus 2 means minus 2, minus 1, 0, plus 1 and plus 2. Very good. So we are having how many orbitals? For L is equal to 2 subshell, how many orbitals? 5 set of orbitals. And what is the quantum number? 3. तो अपन क्या लिखेंगे बोलो बेटा जी? 3dxy, 3dxz, 3dyz, and 2 more, 3dz square and 3dx square y square. 3dx square y square. So this is the relation between, where it is gone, okay. Okay, so this is the relation between orbitals and quantum number. This is the relation between orbitals and quantum number. Relation between orbitals and quantum numbers. So with the help of quantum numbers, we have found the orbitals. With the help of quantum numbers, we have found the orbitals. So what is the representation of orbitals? 1s, 2s, 2pxyz, whatever, 3s, 3pxy, 3pyz, whatever. Right? Is it clear to everyone? Relation between atomic number and orbitals. Clear to everyone? Give me a thumbs up, guys. Clear to everyone? Atomic number and orbital relation clear to everyone? Orbital and quantum number relation clear to everyone? Give me a thumbs up, guys, quickly, please. We'll go further, please. Okay, great guys, great. Chalo, let us come to the next topic now. Now what I'm going to teach is nobody. You won't find generally people teaching this. This is very, very important. Let us rock to this. So now we are going to study something called as energies of orbitals. Wow, what is this? Energies of orbitals. Now, how to find out energy of the orbital? Okay, sir, I know that you gave me a formula. That En, energy of nth orbit, is equal to minus 13.6 z square by n square. Which means, sir, if I'll increase, okay, forget about negative sign. Negative sign means, what is the meaning of negative sign? Either देखो, nucleus, first orbit, second orbit. Negative sign means these electrons are having force of attraction. Because you have force of attraction, energy will be released. If you are having repulsion, energy will be increased. Imagine like this. Let us say you are sitting in a room, right? And 2 friends are there and they are fighting with each other. Energy will increase. If they are attracted towards each other, you will see everybody is peaceful and relaxed, you know. You see how the lovers are? They are very peaceful and relaxed because energy is low. But when 2 people are fighting, when they get married, they start fighting, isn't it? Then the energy becomes high. So whenever there is attraction, energy will be released. And whenever there is repulsion, energy will increase, isn't it? Okay. So negative sign means energy, release of energy. Okay. Now, as I increase n value, forget about negative beta g. Let us talk about the magnitude. There is no sign, okay? Remove the sign. So sign means generally energy ka release. So now as orbit increases, size, as size increases, energy decreases. Wow, sir. As you go away from the orbit, force of attraction will decrease. Force of attraction will decrease. Okay. Now, energies of orbital means what? If you look at the first orbital, 1s. Second orbital mein what do we have? 2s. What do we have in second, bolo beta ji? In second we have 2. 2s, 2px, 2py, 2pz. So what are their energies? 2s ka energy. If you include the negative sign exactly, so n value will increase, overall value will actually minus will become plus, and as you go away from the nucleus, energy actually increases. Okay, let me explain it to you again with the sign. If you include the sign beta ji, oh, what happened? Okay, so if you include the sign, idhar dekhiye, if you include the sign, what will happen? If I increase n value, this value decreases. If I increase n value, this value decreases. And decrease of minus increases. What I want to say is, integer line, all of you have studied integer line, yes or no? All of you have studied integer line. So 0, minus 1, minus 2, minus 3. So this is a bigger number, isn't it? So n value increases, this value decreases, 1 by n. 1 by n value decreases, negative of decrease will increase. So as we go away from the nucleus, energy increases, but force of attraction decreases. Okay. You will study better all these things in 11th class. Let us come to the configuration now. So energies of orbitals. So in the second orbit, what do we have? 2s, 2px, 2py, and 2pz. Now, second orbit, first and second. Second ka energy is more than 1. Second ka energy is more than 1. But what about this one? What about 1s and 2s? 1s and 2s second will be more. But in 2s, 2p, 2pz, which is more? Are they same? Are they same? Are they having different energies? Are they having same energies? Or they are having different energies? How do we know, sir? How do we know they are having same energy or different energy? For that, I am going to explain you a concept known as penetration and shielding. Stick to this, guys. Very, very interesting concept, and I'll close the class with this one. And then we'll start with the electronic configuration tomorrow. Let us come to concept of penetration and shielding. Concept of penetration and shielding. Concept of penetration and shielding. Okay. Now, beta ji, listen very, very carefully, beta ji. This is very, very important concept, and you will read the book, but you'll never understand. Please listen carefully. Okay, guys, come to this. What is the concept of penetration and shielding? So, let us say that we are having the first orbit. Let us say that we are having the first orbit and second orbit, something like this. Now, in the first orbit, we have only s orbital. But in the second orbit, we have 2s orbital as well as 2p orbital. Very good. In the second orbit, we are having 2s as well as 2p. And s ka shape is spherical. This is the nucleus spherical, and p ka shape is dumbbell. P ka shape is dumbbell, and s ka shape is spherical. Now my question is, which will be more attracted? In the nucleus, which will be more attracted? S will be more attracted or P? S is getting attracted from all the directions. P is getting only from these two directions. Which will have more attraction, S or P? Quickly, give me S or P, which will have more attraction? Tell me. S, very good, S orbital, yes, S orbital. Because it will be attracted from all the directions. But P is attracted from only two directions. Very good, beta ji. Chalo, let us come to this. Now, in the second orbit, we are having both 2s and 2p, and as you guys already said that S will be attracted more. Okay. Now, and this is S, and there is p orbital. This is p orbital, this is p orbital, guys. Initially, both of them are having same energy. Isn't it? Initially, both of them are having same energies. So there is a concept which is called as single electron atom, and one is called as many electron atom. Single electron matlab what bolo beta ji? Hydrogen. Hydrogen is a single electron atom. What else बोलो बेटा जी? Helium plus single electron. And बोलो बेटा जी lithium 2 plus single electron. So there are two concepts, single electron and mono electron. Mono electron means what? Helium, 2 electron, lithium, 3 electron, like that. Initially, let us say we are having only 1 electron. We are having how many electron? 1 electron. Now, if there is 1 electron, which will be attracted more? S orbital or p orbital? In case of 1 electron, which will be attracted more? S orbital or p orbital? 1 electron, right? Achha, let me explain like this. Penetration, when it will happen? Penetration means it will come closer. Penetration means S orbital will come closer. Now let me imagine. Let us say that at your home you are a single boy. Listen, beta ji. Listen me carefully. Let us say at your home you are a single boy, single child, and a laddu came to your home. One laddu came to your home and your mother is having that laddu. And you are a single child. Who is going to be penetrated or who is going to eat? Who is going to be eat? Only one child, right? So there is no competition, because you are a single child. You will go and you will eat the laddu. Nobody else is going to eat the laddu. So in this case, when we are having single electron, there is no competition between S and P, because it is single electron. In case of single electron, there is no competition between S and P. But once you have 2 electron, yes, now you are having 2 child. At your home we have 2 child. Now, when the laddu come, what will happen? Nucleus, laddu. Now what will come? Both of you will be fighting with each other. Who should be attracted to the laddu? Who should be eating the laddus? Now the competition starts. Isn't it? Now 2 is the competition, isn't it? Now, in this case, what we are doing is, when there is only single electron, no competition. No competition. S and P will remain at their same position. No competition. But once there is 2 electron, now what will happen? Penetration will start to happen. Penetration will happen. You see, penetration happens means what will happen is, how to represent this? Okay. So this S orbital, because it is having more attraction, it will be coming closer to the nucleus. It will be coming closer to the nucleus. So S orbital come closer to the nucleus. S orbital, because it is having more penetration power, it has come to the nucleus. And once S orbital come closer to the nucleus, now magic will happen. Once S orbital has come closer to the nucleus, and there is electron in p orbital also, there is electron in s orbital also, there is electron in p orbital also, because there were 2 electrons, so there is competition between s and p. Electron is in s, electron is in p. Electron of s has come closer. As electron of s will come closer, what will happen? Because electron has come inside, this will repel the electron of p. As electron come inside, electron will repel, because electron, what will happen? Repulsion. In electron, what will happen? Repulsion. So these p orbitals will be thrown away. These p orbitals will be thrown away from the nucleus. These p orbitals will be thrown away from the nucleus. Listen me carefully. S orbital come closer. As S come closer, it wants to experience more the nucleus. It wants to have more attraction with the nucleus. So what will happen? This is electron, P is electron, it will kick. Hey, P, you go outside. I want to be more closer to the nucleus. Why it is happening? It is happening because electron repel each other. In case of 1 electron, there was no competition. So no penetration, no shielding. But once S has come towards the nucleus, now it is going to repel beta G. It is going to repel p orbital. Because electron repulsion. Now you see, you don't have 2s and 2p the same energy. In the case of single electron, 2s ka energy was equal to 2p, because there is no repulsion, no penetration. But once the penetration happens, जैसे ही penetration हुआ, shielding will happen. जैसे ही penetration हुआ, what will happen? Shielding will happen. So now 2s and 2p is different. Let us say this was the nucleus and this is 2s and 2p. This is 2s and 2p. Now 2s come closer. As 2s comes closer, because it is having more penetration. S ka penetration is more than P. As S comes closer, it will kick P orbital. Chalo bhai, bahar jao. So P orbital goes outside and S orbitals comes inside. Okay, so now what happened is, bolo beta ji, what happened? Now 2p ka energy, because it is away from the nucleus, is more than 2s. 2p ka energy is more than 2s because it is away from the nucleus. Initially, in single electron, beta ji, in single electron, 2s and 2p ka energy is same. But in case of multi-electron, p orbital has gone away from the nucleus, therefore energy will be more. Is this clear to everyone? Is this clear to everyone? Give me a thumbs up, guys. Penetration and shielding. First, what will happen? First, penetration. And once penetration happens, shielding will happen. As you penetrate closer, you want to shield. Yes or no? Is it clear to everyone? Penetration and shielding, is it clear to everyone? Give me thumbs up, guys. No, shielding is attraction, beta ji. Penetration is attraction. Penetration, attraction. Shielding, repulsion. Shielding, repulsion. Shielding, repulsion. Okay. So now I can say that in single electron system, multi-electron system, what is happening? Single electron, 1s ka energy, 2 ka energy more, second orbit more energy, but 2s is equal to 2p beta ji. Then third orbit will come, 3s is equal to 3p, and for third d also comes, equal to 3d. Similarly 4s is equal to 4p is equal to 4d is equal to 4f. Isn't it? This is true for single electron. True for single electron. But in case of multi-electron, energy will not be same. Energy will not be same. So how do we determine energy, sir? How do we determine? Energy is determined by N plus L rule. Energy is determined by N plus L rule. What is N plus L rule? Let me tell you. Just now we saw 2p ka energy is more than 2s. Now tell me, what is N plus L value? What is N plus L value for 2s? 2 for S, L value is 0. So 2 plus 0 is equal to 2. This is for 2s. For 2p, what is N plus L value? N value 2. P ke liye L value bolo beta ji 1. So it is equal to 3. Isn't it? This is equal to 3. 2 plus 1 is equal to 3. So which is having more energy? 2p or 2s? 2p, because N plus L ka value is more. So if you have multi-electronic system which is having more than one electron, we will have N plus L rule. For example, 3s and 3p. 3s and 3p, which will have more energy, bolo beta ji? 3s and 3p, which will have more energy? Tell me, 3s and 3p, which will have more energy? Three S and 3p, which is very good, 3p, right? Acha, if I'll ask you 3s, 3p and 3d, which will have more energy? 3s, 3p, 3d, which will have more energy? 3s, 3p, 3d, which will have more energy? 3s, 3p, 3d. 3s, 3p, 3d, which will have more energy? 3d, yes, 3d. Because N plus L value will be 5, N plus L value 4, N plus L value 3. Now we are coming to the configuration. Electronic configuration. So for electronic configuration, we need to study rules. So with the basis of rules, we are going to define electronic configuration. That we will continue tomorrow. Everybody understood? Please give me a thumbs up, guys. Everybody understood today's class? Everybody understood today's class? Give me a thumbs up, guys. Everybody understood class? Is it clear to everyone? Okay, guys. Okay. Thank you so much. So this was the basis to understand electronic configuration. Tomorrow you'll see electronic configuration will do like this. Okay. Tomorrow we'll do the electronic configuration just like this because we have understood the basic concepts. Okay, see you guys tomorrow. Thank you so much. Thank you so much. Thank you guys. See you tomorrow. Okay. Thank you so much.